Welcome to aminacademy.com. In sequence and series, let us do some example problem regarding sum to infinity. Look at this example. Evaluate sigma n to 1 and 1 to infinity 1 square plus 2 square plus 3 square plus dot 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 n square over n plus 1 factorial. Here the sum is, let it be as, we can write in this manner, sigma n equal to 1 to infinity. Here in numerator 1 square 2 square plus 3 square, like it is a square of natural number up to n, so it can be written as n square over down is n plus 1 the factorial. Therefore the general term of the sequence is, you can write suppose it's a tn n square over n plus 1 factorial. This can be, suppose this n square can be expressed as, suppose here n plus 1 into n, which gives n square plus 1 plus n. So then next n minus n plus 1 plus 1, since here n into n is n square into plus n minus 1 plus 1, so totally it gives n square over n factorial, n plus 1 factorial is as it is. Now further tn can be expressed splitting numerators, n plus 1 into n over n plus 1 factorial minus n plus 1 over n plus 1 factorial plus 1 over n plus 1 factorial. Now here, therefore we can write, suppose t1, the first term, put n equal to 1, it gives, for before that further can be expressed, that is suppose n plus 1 into n. Here n plus 1 factorial can be written as n plus 1 into n and n minus 1 factorial minus, here the second one n plus 1, the n plus 1 factorial can be written as n plus 1 into n factorial, then plus 1 over n plus 1 the factorial. Now this n cut, n plus 1 also cut, therefore tn is 1 over n minus 1 factorial. Here this n plus 1 factor is cut, minus 1 over n factorial plus 1 over n plus 1 factorial. Now we'll substitute the values of n equal to 1, 2, 3, like first n equal to 1, that is t1 equal, here 1 minus 1, that is 1 over 0 factorial minus 1 over 1 factorial plus 1 over 2 factorial. Next like t2, put n equal to 2, means it gives 1 over 1 factorial minus 1 over n is 2 factorial plus 1 over 3 factorial. Like t3 is 1 over 2 factorial, because n equal to 3 here, minus 1 over 3 factorial plus 1 over 4 factorial, and so on. The terms are goes on. Then hence adding column wise, suppose adding these terms column wise, we get sigma n equal to 1 to infinity of n square over n plus 1 factorial is equal to t1 t2 plus t3 plus t4 plus dot 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 up to infinity terms. Now we have the terms. Now first t1 is 1 over 0 factorial plus 1 over 1 factorial plus 1 over 2 factorial plus up to infinity, plus here next is minus, because we are getting here adding the first term 1 over 0 factorial, 1 over 1 factorial, 1 over 2 factorial, like, minus the second terms are subtraction. Start with 1 over 1 factorial plus 1 over 2 factorial plus 1 over 3 factorial plus dot 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 up to infinity terms. Like third term is addition of 1 over 2 1 over n plus 1 factorial. It gives 1 over 2 factorial plus 1 over 3 factorial plus 1 over 4 factorial plus dot 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 up to infinity terms. So we'll get the first the 1 over 0 factorial is 1, therefore 1 over 0 factorial is 1. So the first expansion is e minus, the second expansion is e minus 1, since because there is no one extra here, so it is minus 1, and plus third expansion is starting to factorial. There is missing is 1 and 1 over 1 factorial, so it is 2 is missing. We can write e minus 2. So totally here e minus e plus 1 plus e minus 2, which is equal e minus 1. So this expansion gives e minus 1. We have done. Please subscribe our YouTube channel.